Assalamualaikum and good day. My name is BMFG and my team members today we will be presenting about PETRONAS Twin Towers, world's tallest twin building, with the interactive assignment on stainless steel mechanical properties and its structure. Today's agenda will be introduction of the group members, objectives and problem statements, technical findings, relationship between microstructure and mechanical performance. This is our company logo, Portru Goldsmith, Endless Possibilities with Portru. Here we have our group members. We start off first with Intan Nurshamin Amira. Second, me myself, Sabrini Firdaus. Third, we have Nur Shamila. And the last one, we have Clement Jiang Zi. For the problem statement, we have two problem statements here, which is what are the factors that need to be considered before choosing the 316L stainless steel raw material. Next, to what extent do this material can enhance the stainless steel product's mechanical properties, particularly the tensile properties, by the cold rolling process on the metal plates. We have three objectives for this presentation. The first one is to get better understanding on the properties of the selected 316L stainless steel raw material and its phase diagram. Second, to find suitable 316L raw material based on the tensile test experimentation by using available standard test method. The last one will be to evaluate possible strategy to enhance or modify the mechanical properties of the 316L stainless steel material. Now I will pass on to my other group members to continue the presentation. Thank you.
Good evening. I will be explaining the technical findings of our group, like for this assignment. So the first thing I will present to you is the 316L SS stress over strain graph and also the cold roll 316L SS stress over strain curve. So what is stress? So stress is an internal force induced in the metal in response to an externally applied force. For strain, it is the amount of deformation experienced by the body in the direction of force applied and divided by the initial dimensions of its own body. So as you can see from the graph, the first graph is showing the 316L SS stress over strain graph. For the second, it is the cold roll 316L SS stress over strain curve. So we will be comparing these two types of 316L SS in this research. So this graph will show the behavior of the normal 316L SS and also the cold roll 316L SS. So by analyzing the graph above, we can determine that the tensile properties of normal 316L SS and also the cold roll 316L SS. So the SS curve is divided into elastic and plastic deformation regions, although the shape of the curve depends on the material. So next, I will be present to you the strength and the fracture of 316L SS and also the cold roll 316L SS. So the tensile strength for the cold roll 316L SS is much higher compared to the normal 316L SS that only reach 563.9016 MPa. Like as you can see, like the cold roll it already reached 980.5926 MPa. So the material undergoes plastic deformation before reaching the actual tensile strength value. So the tensile strength is the maximum mechanical tensile stress, so with which a specimen can be loaded. Yeah. So now I'll be explaining the yield strength of the normal cold roll, the normal 316L SS and also the cold roll 316L SS. So what is the yield strength? So it is the point on the stress strain curve, so where the elastic behavior ends and plastic behavior begins. So yielding is the start of breaking of fibers on the sample being tested. So if a sample is being tested and the yield point has not been reached, so the sample will return to its original shape. So basically, yield strength is known as 0.2% offset strain. So the yield strength at 0.2% offset is determined by finding the intersection of the stress strain curve with a line parallel to the initial slope of the curve and which intersects the 0.2%. So for the cold roll 316L SS strain over strain curve, you can see that the yield strength is higher than the normal 316L SS. So for the cold roll, it already reached 975.9096 MPa, but for the normal, it only reached 263.3488. So cold roll has higher yield strength like compared to normal one, so which means like it is ductile enough to be able to hold more stress until it changes behavior from elastic to plastic region.
Assalamualaikum, I'm Amira and now I'll be presenting about the relationship between microstructure and mechanical performance. So what is microstructure and mechanical performance? Microstructure is a very small scale structure of a material, or it is defined as grain of a prepared surface 316L stainless steel material as revealed by an optical microscope. It also has high dislocation density. High dislocation density is the origin of the inverse strength ductility trade-off, as what Clement has explained just now. Based on the microstructure figure, you can see the difference of grain between normal 316L stainless steel and cold rolled stainless steel. Next in order, what is mechanical performance? Mechanical performance are physical properties that a material exhibits upon the application of forces. The purpose is to characterize the properties of materials or providing validation for final products and to ensure safety. It also plays a crucial role in ensuring a cost-effective design as well as technological evolution and superiority. The table above shows the properties of the material based on its tensile strength, yield strength, and ductility. These three properties can be proved by calculating it using its formula. As for example, ductility. By using elongation percent equal to change of length divided by original length times 100, you can get the value in percent of the ductility.
Conclusions: the difference between the normal and cold rolled 316L stainless steel is by the grain size. The strength can be increased by structural strengthening. By reducing the grain size to nanometer range, it can lead to an increase of yield strength and the ultimate tensile strength. So 316L stainless steel is quite superior on its own, but by putting it through the cold roll process, it can be improved significantly. The cold roll process is a process where we put the stainless steel to roll at a room temperature instead of high temperature at 1100 degrees Celsius. So as the metal is formed under the low temperature, the work hardening increase the steel hardness, resistant to tension breaking, and the resistant to deformation, as we don't want it to be ruptured under any stress or load. So that's it from our team. Thank you.